already discussed quantifier like universal and existential quantifier. Next I will discuss negating quantified expression. How can add negation to an expression having quantifier? Let's see one example. Suppose a statement like every student in your class has taken a course in calculus. So that we can write by universal quantification for all x px. Here it's written every student, so that's why for all x px. So px is x has taken a course in calculus and here domain is student in your class. Now its negation will be it's not the case that every student in your class has taken course in calculus, or you can say there are some students who have not taken course in calculus. So that we can write there exists x, there is a student who have not taken calculus. So negation px. So we found for all x px, that is every student in your class has taken course in calculus, its negation means there is a student who have not taken course in calculus, that is equivalent to there exists x negation px. So from this example we conclude that negation of all x px is equivalent to there exists x negation px. Let's say another example. There is a student in this class who has taken a course in calculus. We can write by existential quantification. So there exists x qx. Here qx is x has taken a course in calculus. So its negation will be it's not the case that there is a student in this class who has taken course in calculus, means not a single student has taken course in calculus. So every student in this class has not taken calculus. Both are equivalent like this. Either you can write it is not the case or simply you can write. So every student in this class has not taken calculus. That we can write for all x negation qx. Now from this example we conclude that negation of there exists x qx, that is equivalent to for all x negation of qx. So when we are adding negation before universal quantifier, that is changing to existential quantifier, and in case of existential quantifier, that is changing to universal quantifier. So I conclude that negation of there exists x qx is equivalent to for all x negation of qx. Let's see example 13. What is the negation of statement there is an honest politician? So there is an honest politician means it's about existential quantifier. So there are some politicians who are honest. So we can write as there exists x h of x. So h of x is honest. So now negation of there exists x h of x. So negation of there exists x, it will be for all x. Negation symbol will come inside, so it will be h of x, negation of h of x. So in sentence it will be every politician is dishonest, for all x is for every politician and every politician are not honest. So you can say every politician is dishonest or not all politicians are honest. In any way you can write. Next example 14. What is the negation of the statement for all x square greater than x and there exists x square equals to 2. So first we will do for this for all x square greater than x. Negation of for all x square greater than x. This for all universal quantifier will change to existential. There exists x negation of x square greater than x. So this thing you can write there exists x square less than or equals to x, and its truth value depends on x, depends on the domain. Next we will do for negation of there exists x square equals to 2. Now this Existential quantifier will change to universal quantifier. So for all x, negation of x square equals to 2. This negation of x square equals to 2 you can write for all x, x square not equals to 2. And both truth value depends on x, depends on the domain. Next example 15, so that negation of for all x, px implies qx and there exist x, px and negation qx are logical equivalent. So negation of universal quantifier, that will be existential quantifier. So there exists x, negation of px implies qx. And we know P implies Q, that we can write as negation P or Q. So if there is a negation before this, then it will be negation of negation P, P and negation Q. So here we'll write there exists X, Px and negation of Qx. And it's same as this. So it's proof that negation of for all x, px implies qx is logical equivalent to there exists x, px and negation of qx. Next I will discuss De Morgan law for quantifier. So negation of there exists x, px, that is equivalent to for all x negation of px. And for every x, px is false, then it will be true. So this means for every x, for all x means for every x, px is false, and when it is false, there is an x for which px is true. Next, negation of for all x, px, that is equivalent to there exists x negation of px, and when it will be true, there is an x for which px is false. So there exists x means there is a single x or multiple x for which px is false, then we can say this is true, and it will be false if px is true for every x. So when we are adding negation in quantifiers, existential quantifier will change to universal and universal quantifier will change to existential. In today's lecture, I discussed how we can add negation to quantifier like universal and existential quantifier. In next lecture, I will discuss how we can translate English sentence into logical expression involving quantifier. If today's lecture is helpful for you, please like, share and subscribe. Thank you. Bye bye.